In this video, we will show how to recover data from RAID 0, 1, or 5 created on the Adaptec ASR-6405 controller in Linux. You will learn how to restore files deleted using Shift+Delete or after formatting a partition. We will also examine what to do if the controller fails, one of the array disks breaks down, or if the RAID configuration was accidentally changed. The material will be useful for system administrators and users working with hardware RAID arrays on Adaptec controllers, as it demonstrates real approaches to accessing, diagnosing, and recovering data at the controller and physical disk levels. Capabilities of the Adaptec ASR-6405 controller. The Adaptec ASR-6405 is a hardware RAID controller from the ASR series designed to work with SATA and SAS drives. It supports RAID 0, 1, 5, 10, and JBOD configurations, providing high performance and reliable data storage. The controller is equipped with its own processor and cache memory to accelerate write and read operations, and it allows monitoring of disk and array status through Adaptec utilities, ArcConf, Adaptec Storage Manager. The ASR-6405 is ideally suited for servers and workstations where hardware RAID with data recovery capabilities in case of individual disk failure is required. Recovery of deleted files and partitions. In this part of the video, we will examine the steps to take after accidental data deletion or RAID array formatting. To recover data from a RAID array, the Hetman Partition Recovery program is used. It allows scanning arrays, detecting deleted or lost files, and restoring them with maximum accuracy. A link to the program is provided in the video description. After launch, the program will automatically display your RAID array on the main screen, indicating the file system, in this case RAID 5, total capacity, and available partitions. To begin recovery, left-click to select the entire array or a specific partition and start scanning by double-clicking or via the context menu by choosing Open. If you need to recover deleted files or folders, it is recommended to use the Fast Analysis mode. In this mode, the program performs a comprehensive scan of the file system at the metadata and directory level, detects items deleted by the user, and evaluates their integrity and condition. After scanning is completed, a list of files available for recovery is displayed with a preview option. The user can select individual files or directories for recovery, after which the program restores the data to the selected location with maximum accuracy, preserving the folder structure and file attributes. If the RAID array was formatted or the data was severely damaged, you should use the Full Analysis mode. The program performs a deep sector-by-sector scan of the array, restores all available data regardless of the file system condition, and ensures the return of the maximum possible amount of information. After the scan is complete, the next dialog window will display the RAID data available for recovery. Select the required folders and files and click the Recovery button located in the upper left corner of the main menu. In the window that opens, specify the location to save the recovered data and click Recovery. After the process is completed and the necessary information is saved, click Finish. After completing the recovery procedure, all data from the RAID array becomes available for use again. Additionally, it is worth noting that recovery of data from RAID 1 in the event of controller failure or deletion of the array configuration is possible even from a single disk, regardless of which drive was connected first in the array. Since RAID 1 uses full data mirroring, each disk contains an up-to-date copy of information. The recovery process, in this case, is practically no different from working with a full RAID array or a separate physical disk, as the program correctly identifies the file system and directory structure and allows scanning and data recovery using standard methods without the need to reconstruct the array. Data loss from a RAID array. If the controller fails, access to the RAID array disks becomes impossible without restoring or replacing it. Problems may arise due to physical disk failure, controller firmware malfunction, or damage to the array configuration, which complicates access to data. In such cases, the Hetman RAID recovery program is used to restore the RAID array. It is a powerful tool for recovering data from hardware RAID arrays that supports most common file systems and RAID types. It reads detailed information about the controller that created the array, analyzes the disk condition, and allows reconstructing the array structure and data with maximum accuracy, while preserving file and directory integrity. Recovery of RAID 5 and RAID 0 arrays. Before starting the recovery process, make sure that the storage device intended for saving data from the RAID array has sufficient capacity to accommodate all the information. Be sure to record the exact disk order in the RAID array before performing any actions. Each disk plays its own specific role in data storage and parity calculation, so rearranging them may cause file corruption, disrupt the array structure, and significantly complicate the recovery process. To avoid unexpected losses, it is recommended to document the position of each disk in advance and verify the connections before starting the recovery procedure. After that, launch the Hetman RAID recovery program, which provides direct access to the disks and allows data analysis without controller limitations. Data recovery from a disk image. If physically connecting all disks is impossible, you can use an alternative method. Create an image of one or more inaccessible disks and mount it for further analysis and data recovery. Next, we will demonstrate how to create a disk image and integrate it with the other connected disks. To do this, launch the program, select the disk from which you want to create an image, and click the Save Disk button as shown in the video. In the window that opens, click Next. Choose the option Save to Hard Disk and specify the folder for saving the image. After the procedure is completed, the image will be ready, and you will be able to connect all disks for further work with the program. In the main window of Hetman RAID Recovery, click the Mount Disk button on the top panel of the program. In the window that appears, select Raw Disk Images, click Next, and specify the previously created image. After that, the image will be mounted together with the 3 other disks of your RAID 5. Using the Constructor. If the program was unable to automatically detect your disk array, you can use the built-in RAID Constructor in Hetman RAID Recovery to manually restore the array configuration. To use this mode, you need to know the typical disk array parameters, namely RAID type, block order, block size, and bytes per sector that were specified in the RAID configuration utility when the array was created. In this controller model, RAID is organized in such a way that the beginning of the file system coincides with the beginning of the disk, so there is no need to determine the offset. Reconstructing RAID 5 using the Constructor. After launching the program, select RAID Constructor in the upper left corner of the main menu. In the next window, click Next. Choose Manual Mode and click Next again. On the Settings page, enter the known typical parameters for RAID 5, RAID type, block order, block size, and bytes per sector. In the Available Disks field, select the disks of your RAID array and move them to the Selected Disks field on the left, maintaining the correct RAID order. Then click Update at the bottom of the window. If it is not possible to physically connect all disks, you can use the Add Empty Disk function, which allows you to add an empty disk to simulate a missing drive. It is critically important to maintain the correct disk sequence in the RAID array, as disrupting their order may result in incorrect array assembly and make data recovery impossible. If RAID 5 has lost one disk, array recovery is still possible because this configuration uses distributed parity to protect data. The program can reconstruct the missing disk by calculating its contents based on information stored on the other drives. This makes it possible to restore the full amount of data even if one disk is temporarily unavailable, while preserving the integrity of the file system and RAID directory structure. If the array parameters are entered correctly, at least one partition with the specified file system will appear in the resulting RAID array field. Check the partition to ensure the required folders are present. After that, click the Add button in the lower right corner to add the RAID array to the main page of the program. Automatic parameter detection. If for some reason some of the standard RAID array parameters are unknown, they can be determined by selection using the available options in the corresponding fields of the program. You can also rely on the result displayed in the Generated Array window. Correctly selected parameters usually lead to the appearance of partitions with a recognized file system and readable directory structure, indicating proper restoration of RAID logic and readiness of the data for further analysis and recovery. In addition, you can use the Detect Automatically function, in which the program automatically tests possible parameter combinations that may theoretically correspond to the given array. This makes it possible to determine the correct RAID structure even without initial exact data, although automatic selection usually requires more time compared to manual configuration of known parameters. On the main screen of the program, your RAID is now displayed and ready for scanning. Double-click it or right-click and select Open. In the next window, choose Fast Scan and click Next. After the scan is completed, you can use the Preview function to view file contents in the right pane. Then select the directories and files for recovery and click Recovery in the upper corner of the main menu or through the right-click context menu. Next, specify the location for saving the recovered data and click Recovery again. After that, the program will perform data recovery from your RAID. In this video, we demonstrated a simple yet effective approach to data recovery. Hetman RAID Recovery provides users with a convenient and reliable tool for recovering data from hardware RAID arrays, allowing files and directories to be restored even in complex cases. If the material was useful for you, subscribe to the Hetman software channel and follow new releases by clicking the bell button. Leave your questions in the comments. We will explain in detail all the nuances of working with a RAID controller and the data recovery process to make it safe and understandable. Thank you for your attention, and we wish that your data is always reliably protected.